rationalizing the denominator, the word rationalizing means to get rid of the radical. And then specifically in algebra, it's getting rid of the radical in the denominator. Later on in future classes, it might be in like algebra or in calculus or whatnot. It might be asking to rationalize the numerator. But for the sake of this class alone, we will be rationalizing the denominator only. So as you can see in these problems here, you have radicals in the denominator, and the direction is to rationalize it. So again, rationalizing means to get rid of the radical in the denominator. So the question is how, right? So you will do one out of two things. The first thing is you're going to look at the denominator and you're going to ask yourself, is it a monomial or a binomial? What, in the word monomial, what's the monomial? What's the root word in monomial? Mono, and that means one, right? So it means that there's one term. There's one item and one term underneath the fraction. The word binomial, what's the root word of binomial? Bi, right? And bi means two, right? Like a bicycle has two wheels. A monomial, like monogamy, right? One husband or wife. So binomial means two terms. So you're going to look at the denominator and you're going to ask yourself, is it a binomial or a monomial? The first page here has mostly monomials, right? However, you're going to see starting question 7, you're going to see a binomial. There's two of them. And then moving forward here, you're going to see binomials in the remaining questions. So first of all, I'm going to teach you how to deal with monomials. So whenever you have a monomial, the first thing you're going to do is that you are going to, so if it's a monomial, meaning it's one term, then you multiply the radical by itself. And remember, whatever you do the bottom, you do to the top. So here in this case, I have root 7 divided by root 2. I want to get rid of the radical in the denominator. So in the denominator, I want to get rid of radical 2. What happens if I multiply the denominator by itself? What's root 2 times root 2? Root 4. So you can say it's root 4. But what's root 4? Just 2. No more radicals, right? So in general, if I told you radical 10 times, and if I multiplied radical 10 by itself, radical 10 times radical 10, what do we get? Yep, we get radical 100, which is the same thing as 10. If I said radical 3 times radical 3, that gives you radical 9, which is the same thing as 3. So as you can see, whenever you multiply a radical by itself, right, notice, because the whole idea of radicals is if you see a pair, you get to pull it out, right? So if you multiply it by itself, you get a pair, right? So if you get a pair, you just pull that number out. So whenever you multiply a radical by itself, it just becomes the number inside of it. And by the way, the number inside of it is called a radicand. So that's a fancy math term. It's called a radicand. So if I said square root of x times square root of x, what if it's not a number? What do you think that becomes? Just x, right? It just becomes a radicand because there's a pair, gets pulled out. What if I told you the square root of a happy face multiplied by the square root of a happy face? It becomes happy face. So it doesn't matter whether it's a number, a variable, or a symbol. It doesn't matter how simple or how confusing it looks, it just becomes that item. And notice there's no more radicals. So therefore, in this problem, to rationalize the denominator, we just multiply the denominator by itself. And whatever you do bottom, you must do to the top. So if you multiply by radical 2, you have to also multiply the top by radical 2. And this is legit, just letting you know why. Because what's radical 2 divided by radical 2? Just 1, right? A number divided by itself is just 1. So it's kind of like taking a fraction and multiplying it by 1. If you multiply it by 1, you keep the integrity of the number, right? You're not changing the number. You're just multiplying it by something. So that's why it's A-okay that when you multiply something in the denominator, you do the same to the top. It keeps the integrity of the number. So again, we multiply the bottom by radical 2 to get rid of the radical. The top here was rad 2 times rad 7, rad 14. And I say rad is short for radical, right? So that's radical 14 over 2. What do I do to get rid of the rad 7?
Just multiply by rad 7.
Okay. And what do we get?
7.
7. And what is the top?
4. You also got to multiply by radical 7. And you get 4 radical 7.
4 radical 7. Everyone okay with that? Easy peasy lemon squeezy. All right, let's look at number 3. So here I have rad 7 over 14. Or radical 7 over 14. So when you have a radical like this, you're like, I don't see a radical in the denominator. Well, actually, it is there. It's just written in a different form. The radical here is applied to the top and the bottom. So the top and the bottom is radical 7 over radical 14. So you do need to rationalize that because there is a radical in the denominator. It's just over the whole thing, but it's applied to both top and bottom. So in this case, to get rid of the radical, what do I need to multiply by? I'm sorry? Radical 14, right? And then I could go ahead and blah, blah, blah. But hold up. Whenever we look at a problem, I try to like work smarter, not harder. 7 over 14, can I simplify 7 over 14? What does that become? I'm sorry? 1/2. 7 over 14 is the same thing as 1/2, right? So I could simplify first. So again, you could do the math or you could simplify things first, make it look pretty before you try applying the rules, right? So if I have rad 1/2, this is the same thing as saying rad 1 over rad 2. What do you think is easier to work with? Rad 7 over rad 14 or rad 1 over rad 2? The second one, right? Better to work with smaller numbers. So if I were you guys, I would do this instead of that. But both will lead you to the same conclusion. But always kind of look at a problem and say, hey, can I simplify this first before I do anything with it? What do I do to rationalize this denominator? How do I get rid of the radical 2 in the denominator? You multiply by radical 2. Whatever you do bottom, you do to the top, okay? So as a result, what does the bottom become? 2, right? So rad 2 times rad 2 is just rad 4, which is the same thing as just 2. And what does the top become? Radical 2. And that's it. Okay.